Chrome actually blocks ads on sites that violate the better ad standard. This is a several company organization that came together that said if ads kind of go beyond the pale and do these things on pages, this is not about the ad itself, it's so much as the publisher page and how they put ads on the page. Like they just put way too many ads, or they just have them like way too frequently or things like that in a video. There's a standard. There are humans rating these sites. They put them on a list, on a safe browsing list, and Chrome will block ads on the sites that match. Chrome will unload ads that use an egregious amount of CPU or network. Memory is coming. We have that. We just haven't turned it on. Chrome blocks downloads from ads without a user gesture. Like you might ask yourself, why would an ad ever want to download a thing? I talked to some sort of malware folks in the ads ecosystem, and they're like, this is a major vector for us. Please make it go away. You should not just visit a site and have it download a file automatically. And it was a thing that could happen before we constrained that capability. So I started digging around the code. I was like, hey, we have this ad blocking. What are people doing with it? What are engineers? Have they even seen it? And how are they using it? One of those things I did not know about, and I just found looking at cross-references, was we disallow programmatic focus of ads without a gesture. We don't autofill ad frames. That makes a lot of sense. There's a memory pressure signal that Chrome gets. And when it has to figure out what do I dump right now because I'm just running out of memory, ads are first to go. And there's more stuff in progress that I'd hoped to talk about today that I can't. But needless to say, this is not a, hey, we did this and it's cool, it's in the past. Like, there's more coming. All right, so the main thrust of the talk is, hey, this exists, it's doing cool stuff. How do I use it? So I'm gonna give you the how do I use it, and then I'll go into the like, what's the magic behind it. So if you're sitting in the renderer, this is BlinkOn after all, you might ask the question like, is a thing that I'm looking at right now ad related? Is an element ad related? Well, there's element is ad related. And that really is implemented for image and frames. You can ask for a given resource request, is it ad related? You can ask for a frame, is it an ad frame? There's some timing involved, like we make the decision on this is an ad or not, and you want to call this function after that point. But that's the basic surface. And then at the bottom here is the function that I think is just sort of most interesting of all, which is just utilized heavily everywhere, is ad trackers, is ad script in stack. This is the one you call when you're like, hey, I'm in Blink, I'm doing something on behalf of some script right now. I don't know, like, what script it is. I don't know, like, yeah, basically, who am I doing it on behalf of? And you can ask the question, well, is ad script currently in the stack? And if it is, then I'm doing it on behalf of ads. And that's how you like sort of make these capability constraints and interventions. All right, so if you're in the browser, we don't have quite as much API surface. On navigation request, there's a navigation request info, and you can ask it like, is it an ad tagged navigation? There's a sub-resource filter observer manager, and this is just an observer you can listen to, and it will tell you when it's decided on a given document whether or not that document is ad related. There's some other things. I think you can actually, on a render frame host, you can get at this somehow. I didn't find the code when making the talk. And then in the network service, we take this whole like, oh, we're doing a resource request, is it ad related? And we plumb it over Mojo over to the net service. And so the net service knows too. All right. So that's the, hey, I'm an engineer, I wanna use it, how do I use it? You can go back and reference the slides anytime. That's where all the functions are. But now it's time for the magic. So there's two major parts. I talked about this, like we block ads that match the better ad standard. Then there's we track ads and we know what they're doing on a page. Blocking ads is very traditional. This is a thing that we all have seen extensions for. It's been around a long time. It's a well-trodden path. And we have our own implementation of that. And then there's the tracking half. The blocking half is someone makes a filter list. We could make one, someone else can make one, you ingest it, and then on every single navigation or sub-resource request, you just match it against the list, and if it matches, you deny it. On the tracking side, we don't actually block anything, we just watch. And then we'd want to tag everything that's ad related. So to talk about blocking, you kind of have to understand how ads actually wind up on a page in the first place. And it's pretty straightforward. The ad tech wants to make it as simple as possible to help the publisher. The publisher is a page that has like ad slots on their page that they want to sell, right? They've got content and they want to sell this space on their page. And so they talk to an ad tech seller, and the seller, they make a relationship with them, and then the seller says, hey, just put this snippet of code in your page. And that snippet of code is just a script tag, typically, maybe a couple other lines above it, but it just insert this script, it'll download and it'll do its thing. This is called a loading script. So it's really all the publisher has to do is like this one thing. They add the script, and then the script starts looking around saying, okay, how many slots do I need to fill? How big are they? What page am I even on? Does some local calculations. And then it like puts together its context and sends it to the server side saying, hey, let's do a fetch. Give me the right ads to show. The response might include URLs. It might include, in fact, the body of the ad content. Doesn't matter. The point is the ad tech script fetches what needs to be displayed and then shoves it in an iframe, potentially, or it can even just be in the publisher's mainframe itself. So if you wanted to block ads and you're making a filter list and you don't want it to be enormous, you might do the obvious thing and look and say, hey, look, there's this loading script. If I block that, then nothing else happens after that. I don't need to worry about all the possible ads that could be displayed on a page. I don't need every single ad resource to be in my list. If I can get at the root of it, then everything else I get for free. And that's basically ad blocking in a nutshell. You have a list that has rules, like they're tiny and you can't see them, but it's not necessary that they get the universe of all possible ad resources. They just need to get the loading script and some other common things. It's regex-like with a lot of modifiers on it, saying like, oh, if it's third party, it's okay. If it's third party, it's not okay. Or if it's script, then and it matches this, then I want to block it. Otherwise, no, and things like that. And this is a list of rules to block resources. And then there's also the other thing that matters is there's a list of CSS rules. And if the CSS rules match content, then they will hide that content. So the sub-resource filter that we use in Chrome is only looking at the blocking rules. But one thing to think about in the future is we should also be looking at the CSS rules. All right, so what is Chrome actually using? We have a GitHub repo, it's public, with the current list Chrome is always using, plus everyone it's ever used in the past. And we start with easy lists. Filter list. This is a public list made by a company that makes the most popular ad blocker out there, AdBlock Plus. And we don't modify it in any way other than we shrink it. And we shrink it because, especially back in 2018, we wanted to ship this thing on Android, and memory was a real issue, and this thing was many megabytes. So we needed to make it smaller, and so this is not magic, but we're like, okay, we need to make it smaller. Well, why don't we just take the most popular rules? How do you find the most popular rules? You go to the HTTP archive, do a big query, and look at every single sub-resource request, and then match it against the list and see which comes up most often. That's what we do. We take the top 1,000. We add all the allow list rules to prevent breakage, and we remove the CSS rules for now. And we do that monthly because HTTP archive updates monthly. And that gets shipped out via the component updater in Chrome. All right, so the blocking part is take this list, ingest it. And I feel bad saying this because it's really clever. There's lots of like smarts and how you actually like quickly look at this list of thousands of rules potentially and like compare it to a sub-resource request. But for every sub-resource request, you do this lookup, you see if it's there. If it doesn't match, then it's fine. If it does match, it's an ad, you block it, or you mark it as an ad, depending on the mode you're in. All right, so that's the sub-resource filter. It does the blocking, and it also can say, hey, this resource was or was not an ad, based on what the filter list said. But if we're not blocking, and now we actually just want to monitor ads, we have a problem in that the loading script part is still running, and then it goes and loads all those things. And so all those URLs and all those ad resources are actually there, and we need to somehow identify them. The filter list by itself is not enough. It doesn't include all the ad resources. So the obvious thing is, oh, let's just make a bigger list with all the ad resources in the world. That's kind of hard and very, very large. And remember, I mentioned memory constraints. Next question is, hey, it's 2025. AI solves everything. Well, this was 2018 at the time, and we wanted something cheap. And I think it's a thing worth exploring. I have read academic papers using AI for this kind of stuff, but we have a tried and true method, which is, think of it like a trace and garbage collector, where your root set of objects are those resources that the filter list matches. And then everything those resources that the filter list matches, like what they do, you trace the things that they do and mark them as ad related too, transitively. So for instance, an ad script creates an iframe, or it fetches a script, or it does a doc write, or it creates an image. At each of these events, you say, ad script did that. So that image or that iframe or that script is also an ad. And then in the future, when that transitively tagged object creates an iframe or creates an image or whatever, it also will be marked as an ad. All right. So how does Chrome, this is the interesting part, how does Chrome monitor what ad script is actually doing? We have that loader script. It wants to create frames, it wants to fetch things. How do we actually say, oh, at the time of this iframe creation, we know that that was ad script doing that. And that's what we have this function is ad script in stack for that I mentioned earlier. It does what it says. It can be called anytime, such as when fetching a resource, creating a frame, opening a pop-up, downloading to disk, etc. And the basic idea is these 3 bullets here is, you want to tell the caller, hey, ad script is currently running the JavaScript stack. We're lucky that we have this JavaScript stack, and that V8 gives you this beautiful annotation. This is largely due to DevTools. Thank you very much, DevTools team, showing you for each stack frame, the script name that's running and the function name, etc. So you could implement this as simply as, hey, is ad script in stack? Well, let's get the stack, look through each script, match it against the filter list, and if anything matches, return true. But getting the full stack trace is slow. Comparing every script to the filter list is slow. This is missing those extra marked things we were talking about. This is just what the filter list matches. And it misses async stack frames as well. So here's an example stack trace that you can see in DevTools. And this is really just to show you that the script name is there and it shows show ad simple. And there's this notion of a top of a stack and a bottom of a stack. When I say top, I mean this is what's currently running when the stack trace is created. And bottom is what Blink executed. It told V8, I want you to run this top level script, or I want you to run this function in this script right now. So the first question is, well, do we really need to check every stack frame? And ideally, the answer is yes. But realistically, we can make do pretty well with looking at the top and the bottom of the stack. And asking the question, are the top and the bottom ads? And we can look further if we have to later. But it turns out that DevTools folks put a lot of effort into getting just the top stack frame really fast. So if we can do that, then that really helps us performance. And that is what's currently executing. That's the thing that's currently downloading or fetching or whatever. So it makes sense that we'd want the top of the stack. And then what about the bottom? That's what Blink actually called. It said run this top level script like that loader script.js. And so we want to make sure that we catch that as well. The bottom is actually pretty easy to capture. The bottom is anytime Blink calls out and runs code and says, okay, V8, I need you to go run this thing. We hook into that moment and say, we have an observer class, the ad tracker, that says, let me know anytime you're about to execute anything in V8. I'm going to check if that thing is an ad related thing. And if it is, I'm just going to increment my counter of is ad script currently running? And then when that execution finishes, I decrement my counter. And then if anyone calls is that script in stack, I can just check my counter and see if it's greater than 0. All right, the next problem is that matching every script in the stack is slow. Well, we're not looking at all of them. We're now only looking at the top and the bottom, but we don't really want to check the filter list each time. This is straightforward. We want to know with every sub-resource request if it's an add anyway for other reasons. So since we're already like tagging each request, we can just look at that anytime a script is tagged. You can say, hey, a script was tagged in this context. We should remember that. And that's going to be part of our set of now part of our set of add-related scripts in this context. So that means if an add loader loads jQuery.js, then that jQuery will be tagged as an add in that context. But if you're in another context where jQuery is loaded, but it wasn't add script that loaded it, it won't be marked as add script. So it's important to have per context mapping of scripts to whether or not they're add related. All right, the point here is really just if we want to transitively include and mark things, we can't just ask the sub-resource filter, hey, did you actually see this resource in your list? We also have to ask, call is add script in stack at that point and say, oh, it turns out the loading script loaded this, therefore this is an add too. So there's certain key moments that we have to call this function. Any script fetched is tagged as an add script. Any iframe created with an add script in stack at the time is tagged as an add frame. And then any add frame and anything that happens in an add frame is tagged as add related. All right, and then the last issue I want to talk about here is async stacks. You can imagine calling like set timeout, you put some Lambda function in and run later, and then when you execute, what does the stack look like? Well, it doesn't mention adds anywhere in the stack at that point when you execute, because it's just running this Lambda function, and that's it. That's the whole stack is this Lambda function. So DevTools actually saves us once again. They have another hook for this. They also care about the async stack. And so they say, look, anytime like a callback is registered with native code, we get an event. And they say, we're making an async event here. And so we say, great, we're going to call is that script in stack at that point. And we will label that async event as add related or not. And when that async event actually eventually runs, the callback runs, we have a bool associated with whether or not it's add related. So when that Lambda function is created, like there's already a hook into Blink, we see it and we say, yep, that's add related. And then sometime later that Lambda function executes and the callback executes. And we remember that like no matter what the current stack is, we know that the stack that created that Lambda function was add related. So here's what the actual function looks like in the end. We can early return true if the, like, are we currently executing add script directly from V8? Counter is greater than 0. If our async event tag is greater than 0, or if we're currently running in an add frame, in all those cases, we can just immediately return true. Otherwise, we grab the top frame, look at the name of the script, and see if that's in our per context map. And otherwise return false. All right, so now we're like, that's the basics of how it works. Is it any good? So first, let's talk about its shortcomings. I think the most common sort of thing we've come across, especially with heavy ads, because we label ads as heavy, they take too many resources, and then we unload them if they take too many. And so then we'll get a customer complaint saying, hey, on my page, this wasn't an ad, but you unloaded this content. Why? So there's two shortcomings here. One is our DevTools integration isn't good enough. We're working on that right now. We want to make it easier for people to understand why their content was tagged as an ad. So that's being worked on actively. The second is that, actually, this is the most common thing that's not in the slide, is that people will overwrite the JavaScript APIs because they want to monitor everything that happens on a page. And so it's often ad tech code that will say, hey, I want to know every time an iframe is created or every time anything like this happens, and they'll override the API function. And so this ad tech script is always in the stack, no matter what's happening on the page. And so then we'll catch it and say, oh, this content is ad. When really it's not, it's just this monitoring code that was on their page is ad related. And so there's this sort of like complication factor there. Another case is that ad tech will actually like add content for you on your behalf. I feel like they have the platform of their own to say like, hey, you want to build a web page? Here, do it through our ad script. It's kind of weird, but it exists. That has been much less of a problem because if you do that, then everyone out there with an ad blocker can't see your page. So that's less common, but does exist. We miss CSS filter rules. So there's a lot of ads that like we don't block at the network level that ad blockers will at least hide with CSS. And we don't have any of that. That's a thing, so that's a to-do for the future. So the kind of ads we are good at detecting are like display ads. These are ads that are like in little iframes on the page, but not like the in-stream video ads you'll see on YouTube or something like that. And it is possible to hide from the ad tracker. I could give a talk on the various mechanisms you could use and the ways we're addressing them. They all have possible solutions. It's a cat and mouse game. We address them as we need to. All right. So then the is it good part. How do you measure whether your ad tracker is actually working? One metric we came up with, or an experiment we came up with, was to say like, let's take 10,000 page loads and shove them in web page replay so we can replay that page load 1,000 or as many times as we want, and it should be fairly deterministic. And then load the pages with full easy list blocking on, with the full list, not our smaller list. And basically count the number of resources that load. Now, load those pages again with ad tracking on, not blocking, and record just the ad resources that weren't labeled, or just the resources that were not labeled as ads, and ideally these should be the same number. So you can say, yep, we loaded these resources. And it's not just a count, we're actually looking at the names of the scripts, or the resources that were loaded. And we found that we had a 99% similarity across all pages between the two. And at the median, it was 100%. That's given the fact that our list is much, much smaller than the full filter list. We are monitoring and not actually blocking content. And we're not looking at the whole stack. So this experiment is a few years old. I need to run it again. The infrastructure that was running has gone away, unfortunately. So I need to find a new way to do it. But yeah, I think we were pretty happy with these results. And that's it. So if there's any questions.
On the previous slide, how did you pick the 10,000 pages? Some top.
I don't remember. There was a list of 10,000 pages that we had in our infrastructure, and sure. I wish I could tell you, but I don't.
Okay. So I understand the use case of sub-resource filter blocking ads, yep. But for monitoring ads, what's the browser's output with that information? Are we telling users like, you've seen X ads today and such a flyout? Are we using attribution reporting somehow?
Nope, it's not tied into any of that. It's mostly used for constraining capabilities. There are metrics as well in terms of like understanding our browser engineers breaking the advertising world at any given moment. Like it's a good one to know if there's any regressions.
Okay. And then another question. So 99% similarity across all pages sounds really good, but I don't have the context for how many resources are loaded, across 10,000 pages. Is 1% like a million resource loads? Like how big of a number are we talking here?
So that's a great question, and this is old, and I don't remember.
Okay.
This whole talk was me going down memory lane and putting together things. I'm sorry. I can try to get that answer.
I was just curious.
Can you talk about maybe go back to your first slide that had all the things we do with this?
Yep.
And can you just talk about the intersection with web standards on those things? Do you know to what extent? Sorry, no, I'm just asking you tough questions. I mean, it's fine. Like we do all sorts of the web is unspecified.
All right.
Right? Lots of behavior in the web is unspecified, but I'm wondering to what extent.
So, all right, let's talk about better ad standard and blocking. That list of sites that should be blocked is part of the safe browsing list. so that can be ingested by anyone. How you block ads on those sites is not standardized. So the sort of sub-resource filter list that we choose to use is different from Mozilla's, which uses disconnect.me. I don't know. I think Edge actually implements.
We use the easy list as well, but we have some downstream modifications.
Okay.
I'm wondering about things like, disallowing programmatic focus in ad frames, right? Like, do you know offhand what the HTML spec? I mean, I guess that's one you just found, right? But I don't know.
I literally found it looking through the code. Like, hey, what are people doing with this?
Yeah.
I don't know. Blocking downloads and ads was like in the intervention list and the intervention community, not community group. What was the?
We had a YCG group.
It was a YCG group.
Yeah.
That dissolved. But it couched itself in the sort of the browser may choose to do something here,
Yep.
like language, right?
Yeah.
So it was not standardized across browsers. I think Edge is the only one that has the same sort of tech that is using it as Chrome. Heavy ads is again used by Edge, and I don't think anyone else. And there was no standardization process there. And then on the autofill, that's a Chrome feature, not a cross-browser thing.
Yeah, I think actually the HTML spec is quite clear that autofill, whether or not autofill triggers is a implementation defined, right? So, and that's pretty common that we have things in the specs that, hey, at this point, this is a user feature, and we're not going to specify exactly when it triggers.
But you're right, the programmatic focus one, that seems like a thing.
I suspect if we went searching, I'll go looking after. I suspect there's probably some language in there about it, around focus may require user gesture.
Should we try to standardize on things like that? Like,
I mean, we should at least. I think we should. I don't think we need to. I think there's room for browsers to compete on some of these, but we should probably make sure the specs are clear in allowing some variable behavior.
Privacy sandbox. Instead of the browser sending a fetch request to an ad tech server to run an ad auction, Chrome offers locally hosted auctions and then also T-based auctions. Is there any talk or interest in porting some of this tracking functionality over to these different auctions? I without having looked at the code myself at all, like,
so
it's like there'd be some changes required.
some changes would be required, yes. It's very trivial for the browser to know, like the output of an auction and where that winds up loading and things like that. It's not there yet. But it's, I think the places that you would insert, there's a couple thoughts there. One is, while the ads APIs are sort of designed for ads use cases, they aren't necessarily always going to be used for ads use cases. So you don't necessarily want to label a thing as an ad just because they use protected audience, for instance, although you probably do. But that's the thing to think about. But we could certainly match the sort of scripts being used in those auctions against the filter list.
Yeah.
And use that.
It's a good idea.
We've got a question online. Andrew? Oh.
Hi, so there is a different way of tracking the provenance of tasks in Chrome, which is called task attribution. And I was wondering how this interacts with that, if at all. Was that considered? Was that not even? Did that not even exist when this was started? Like, I'm working on a T-Thread proposal called async context, and this would basically do the same that task attribution does, or well, I guess it's. Except it would be exposed to user code, so you could set a value that would be propagated across an async stack, so to speak, and it needs to be tracked through set timeout, through async events, and a number of places. And I was wondering, like, could we work together or something, or why is there why isn't there already being some cooperation there between this ad tracking and task attribution? And yeah, could we work together on that?
That's a great question. I actually don't know about task attribution. Is this part of like performance teamwork?
Yeah, I think it's very new for performance metric stuff, right? I think
Got
it's
it.
the thing Yoav worked on.
Got it. Okay, so the answer, you kind of hinted at it before, is this came about in 2017. This long predates that. The ad tracker does. Why they're not integrated? That's a good question. I think we should work together and try to figure out if there's ways that we can sort of simplify our code.
Yeah, I was talking to Scott Hazley, who is working on task attribution. I am not. I work at Igalia and I'm working on the 639 proposal. But I was talking to the task attribution folks because that is like they're doing the same. They're using the same V8 API that we would build into this proposal, and I think they said that. Like I guess the use cases for task attribution and for ad tracking might not be the same in terms of what events need to be propagated, but that might be like those use cases might overlap. Like the ad tracking ones might overlap with the async context one, even if it doesn't with task attribution. So yeah, we should talk.
Yep, that sounds good. I'd be interested to learn more. Thank you.
Sure.
Do we have a?
The next talks are starting in 1 minute.
Okay, here we should go.
Thank you, Josh.